Hey guys, welcome to Bennett's Minutes. And today we're going to talk about 4.02. Let's do a quick little rundown of 4.02. All right. If you remember, we got to a point where we were talking about the end behaviors of a polynomial, the end behaviors, right? Okay. What did we find out about the end behaviors? Well, we found out that based on the degree of the polynomial, if it was even or if it was odd, and the polynomial's leading coefficient, if it was positive or negative, it affected the end behaviors. So we found out some things about the even degree functions, right? How their end behaviors behaved. And the big thing about the even degree functions we found out is that on the ends of a function, if we graphed it, the ends would go the same way as long as the degree was even. And remember, the degree is the highest exponent of that polynomial. So the term that has the highest exponent is going to be your degree. As long as that number was even, no matter what even number it was, we knew that the ends would be doing the same thing. Now, to determine the direction of the ends, we would look at the leading coefficient. If the leading coefficient was positive, we knew the ends would be going the same way and they would be pointing up and up on the left and the right side of the x-axis. If it was even degree and if it was negative, they would be going the same way, but because it's negative, both ends would be pointing down, down. Now, I hope at this point you have your guided notes and you're filling this in so that way you can be up to date and ready to go when we have our next lesson. Moving right along, we looked at odd degrees. Odd degrees, we noticed polynomials with odd degrees did the opposite, right? So their end behaviors did not go the same way. They went opposite directions. Now, if I looked at that leading coefficient on an odd degree function, if it was positive, the end behaviors of the function would do exactly what we felt, which means if I was on the negative side of the x-axis, I would, because it's negative, my feeling is that f of x is going to be going down, right, in a negative direction. And if I was on the positive side of the x-axis, f of x would do what I felt. It would be going up. Notice, though, with odd degree functions, if it was odd degree and it had a negative leading coefficient, the end behaviors did the opposite or a flip of that, the opposite of what you felt. So if you were on the negative side of the x-axis and you looked at a function like that, the end behaviors of that function would be going up instead of down. And if you were on the positive side, it would be going down, okay? So even degree functions went the same way. Odd degree functions went opposite ways on the ends, all right? That is what we learned. That was the big idea. So we also learned how to describe it mathematically. A lot of you all could put it into words, no problem. You could tell me the end behaviors. We did a warm-up. You guys got it. So now we talked about putting the math notation on it. And remember, this is what I call the hack to describe it in behaviors. And that idea was that this is going to always look the same. Remember, if we talked about as x goes to negative infinity, we were just talking about a side of the graph, right? X going to negative infinity just referred to the left side of the graph, right? The left side, or us being on the negative x-axis, right? And as x went to positive infinity, that was the right side in behavior, right? We're talking about the right side in behavior of f of x. And that's just saying the positive x-axis. We're pretending like we're looking from the positive x-axis standpoint. And we know, if you think about it, guys, left and right side, that's not going to change, right? The negative x-axis stays where it's at. So I told you guys this won't ever change, this part here. That'll stay the same. So the only thing we have to worry about was the direction that f of x was going. We would just fill in right here if f of x is going to positive or negative infinity based upon the leading coefficient, based upon the degree of the function. So let's go ahead and practice writing in behaviors looking at functions, okay? Here we go. So I'm looking at this function, and the first thing I want to do is I'm just going to write out my end behaviors, all right? So Here's my end behaviors. Remember, they don't change. F of x is going to do something as I'm on the negative side of the x-axis, or as x goes to negative infinity. And f of x is going to do something as I go to the positive side of the x-axis, right? Or as it goes to positive infinity. Now I'm just looking and I'm thinking about my chart. Okay, is it odd? Is it odd, positive, or negative, or even negative or positive? All right, which one? So I'm gonna look. I look at the degree, which means the highest exponent. Notice that's 5, and then I'm gonna look at that term's leading coefficient. Notice the coefficient is negative, so this is a odd negative. Remember, odd negatives, odd went different directions, and the negative on it did the opposite of what you felt. So if you're on the negative side of the x-axis, instead of f of x going down, it went up. And we know, since this is an odd degree function, the end behaviors do the opposite thing. So we know on the positive side of the x-axis, f of x is going down, or the graph is going to be going down. So if I was to graph it, if I was to graph this function, this is how the behavior of the ends would look like, right? And so if I'm filling in the description, I'm going to look, and I see on the left side of the x-axis, f of x is going up. So it's going to be going to infinity, right? I'm just going to fill an infinity in here. And on the right side of the x-axis, f of x is going down. So I just have to put a negative infinity. Look at that. That wasn't so bad. All right, let's move on to the next one. Again, I'm going to just copy out my end behaviors in advance because I know this pretty much stays the same. F of x is going to go somewhere as I'm on the left side. And then f of x is going to move somewhere as I go to the right side. Okay. So now it's just one of those things where I figure out, okay, which way is it going to go? And I'm thinking about this. I look at the degree. I see that the highest exponent is odd. I see the leading coefficient is positive, right? Odd positive, that's going to go exactly how we feel, but in different directions, right? So if I'm on the left side of the x-axis, it would make sense that f of x, if I'm on the negative side, would be going down, right? Again, odd positive. Which means on the right side, it's going to go up. F of x is going to go up. So if I fill in for this, I'm going to look on the left side. I see f of x is going down, or right here I'm writing as f of x goes to negative, or f of x goes to negative infinity. Now on the right side of the x-axis, I notice f of x is going up. So I know it's positive infinity. Last one, guys, if I'm looking at this one, I write my end behaviors because I know they stay the same. And then I'm just going to think to myself, what is it? Is it odd or even degree? And is my leading coefficient positive or negative? And if I look at this, I notice this one is a odd negative. Okay, so this is odd negative. So the end behaviors are going to do the opposite thing, or the end behaviors are not going to be opposite. I'm sorry. They're going to go the same direction, and it's not odd. I don't know what I'm saying. This is a even degree, right? So end behavior is going to go the same direction, except because the leading coefficient is negative, the end behaviors are going to go the same direction, but they're going to point down, right? So both sides are going to be going down, which means on both sides of the x-axis, f of x is going to negative infinity, right? So let's look at this in terms of a graph. Now I don't have a leading coefficient to look at or a degree to look at. How would I do it? Well, all I'm going to do is just look at the graph and look at the end behavior, right? Remember I told you guys to pretend that you were driving along the x-axis in a car, right? So you're just driving. And what do you have to do to see f of x? Do you have to look up or do you have to look down? And notice for this, if I was driving along the negative x-axis, or as x goes to negative infinity, I would have to look up. So what that tells me is f of x is going to be moving to infinity, right? Because f of x is going up as we go down the negative x-axis. Now what happens as I drive down the positive x-axis? Where would I have to look to see f of x? Oh, I would have to look down. So that tells me as I'm on the positive side of the x-axis, or as f of x goes to infinity, or as I'm going as x goes to infinity, f of x is going to be moving to negative infinity. And check this out, guys. Even though we don't see the equation, I bet you guys can look at this now and you can tell me if this is even or odd, right? Is this even or odd? And I'm going to give you a second to answer or just think about it in your head. Would this be an even or odd degree polynomial or function? And I hope most of you guys said odd. And we know that just because the polynomial is going different ways on the ends, right? So the different ways tells us it's an odd function. The other thing I want to ask you is the leading coefficient positive or negative? Is the leading coefficient positive or negative? Well, if I'm looking at this, notice f of x does the opposite of what I feel. When I'm on the negative side of the x-axis, and behavior goes up. When I'm on the positive side, and behavior goes down. So that means, that tells me that if I was to get the equation of this polynomial function, the the leading coefficient is going to be negative, right? Go back to your chart. If that confused you a little bit, go back to your chart. Remember the rules of determining the direction of a polynomial, right? And whether or not the degree was even or not. So we're just doing it backwards now. Now they're giving us the graph. We're determining the end behavior, and then we can determine and kind of know what type of polynomial we're dealing with. All right, let's go to this last one, guys. This is important. If they were to give you a table and tell you to describe the end behavior, right? Again, you're going to just write out your basic end behavior, right? X goes to something as we're on the left side of the x-axis, and f of x goes to something as we go to the positive side of the x-axis. Now, we're not going to freak out, okay? Even though they don't give us, the graph, they don't give us equations, we're not going to freak out. We're just going to keep this same concept in mind, and you do not have to graph this. Just think about it. What is f of x doing? Notice this side or these points represent the function or f of x. Now they call it g of x, but that's no different than saying f of x, right? It's just some function. So this side represents what's happening with f of x. This side represents the x values or the x-axis. So if I'm talking about what the function is doing, if I'm on the right or the left side of the x-axis or the negative values, I'm going to look here when x is negative. And I notice as my negative values get bigger and bigger on the x-axis, f of x gets smaller and smaller, right? So that lets me know that f of x is going down because it's getting smaller and smaller. So I know f of x is going to negative infinity. Over here, when I'm looking at the positive side of the x-axis or when x is positive, and I think about, okay, what is f of x doing? Well, on the positive side of the x-axis, as I go further and further down the positive, f of x gets bigger and bigger, right? So I know f of x on the positive side is going to infinity. And from this, I can tell something. Because f of x is going two different ways on its end behaviors, I know the degree of this polynomial has to be odd, right? Has to be odd. And because it's a negative on the negative side of the x-axis, and f of x is going positive on the positive side of the x-axis, that tells me the leading coefficient of this function has to be positive. All right? So what I want you guys to do at this moment is I want you to go to your Khan Academy. Make sure you're logged in to Khan Academy. And there are just some wonderful practices on Khan. I gave you an assignment where I had you guys do the end behavior. Make sure you add in this class code here to get yourself joined in if you have not done so. You're going to go to your profile. You will hit the assignments tab on your profile, and you're going to take this end behavior lesson before you take quiz 4.02. Is this a part of your grade? Is it required? Absolutely. Okay. So in